everyone. Yes, so I guess I'm the bridge between the pure gallium nitride and the pure silicon carbide world. So Navitas has both technologies. When we began, the company was founded in 2014. We were obviously concerned about quality, make sure the product is correct, and then bringing that to the market as well. So one of the first things that we did with any new technology is that you test it. And you need to test it where the customer will use it. So we focused on high frequency. Our products are specified at 2 megahertz. So the half bridges, the singles, the GaN sense, everything is 2 megahertz. So we needed to test at high speed. And when we did that, we found problems with the technology and had to correct that. So we also have to, we've talked about the different tests. Silicon tests don't apply to a high frequency material. So you have to think about new ways to do it. So we did that, we designed around problems, we worked with our partners to fix them, and then we went to the customers. And we were all prepared to fight the battle of quality with E-mode gallium nitride, and we found out that someone had already done that. Thank you very much, Dr. Lido. So I have to say thank you for the pioneering work in E-mode GaN. Thank you. So when we went to a customer, they said, yeah, we know that. We trust that. So it was a good start. And then with the GaN Power IC, we really focused on, once we got a reliable product, make a reliable system. And for us, that's the integration, the monolithic integration of a GaN driver as well as the GaN power. So the output of the driver is the gate of the MOSFET. And that means we can correctly control the voltage for the right RDS on and also for the right reliability. And that means you can protect that. And because it's an IC, you can then do cool things like 2 kV ESD protection, which you can't do with a discrete device. So we're really focused on that. And on the left-hand side, this is a discrete approach to a half bridge, and then the integrated approach to a half bridge. And you can see that you can get some pretty tricky ringing and glitching in the system. Again, with the system and being an IC, you can bring in features and functions. We've brought in lossless current sensing, for example. Also, short circuit detection and then autonomous turn-off protection within 30 nanoseconds. So that's 6 times faster than a discrete implementation. So very reliable product and making the system more reliable as well. So we shipped over 75 million high voltage power ICs. We're running at less than 1 ppm, over 500 billion hours in the field, and we're the only company with a 20-year warranty on our GaN power ICs. So we believe in our quality, and that's something that goes from our start in fast charging into long-term solutions like solar power, EV, data center. People need to see proof before they start to trust. On the silicon carbide side, again, this is a focus on how the device performs in circuit. Yes, they pass the tests. Yes, they're fully qualified. But what do they do in real life? And on the right-hand side, this is a like-for-like comparison. Half-bridge application, running quite fast for silicon carbide. This is 150 kilohertz half-bridge. And you can see that on the left, this guy's running hot, this guy's running cold. So like-for-like conditions, 25 degrees C cooler on the case, translates as 3 times longer expected lifetime, and that's what we're getting into. We obviously have a big avalanche advantage, high power paralleling. Obviously high power systems, you want to put chips in parallel. You can only do that with a stable threshold voltage. So we have a very stable threshold over temperature as well, so that's another safety for the system. And then short circuit. Sometimes things go wrong, and if they do, you have to ride through it. So this is another feature for us. So whether it's the gallium nitride side with GaNFast power ICs, silicon carbide side with our GeneSiC products, reliable product, and helping the customer get a reliable system. Thank you.